very, very useful. What is fraud? Fraud is those rare transactions which do not follow the normal pattern. Right? If you have all of this data which are normal, a small thing which is very different and far from others. And detecting rare events, detecting rare patterns is a very common business need. Today, for example, if you are normally used to buying things online, your credit card in India, right? Suddenly, your credit card company detects a transaction from Pakistan. Will it allow? Because it has created a mental model of what is the usual transactions. And now with an unusual transaction, what happens? It creates a flag and stops the transaction, gives you a call. Did you travel to Pakistan? Are you doing this? So when people go to outside from India, you have to inform your credit card company that I may be using a credit card in this country, only then it will allow. Because by default, by pattern analysis, it says that which is always not a normal pattern of where you're traveling, it is unusual country. Fair enough? So you see, there are several examples where anomaly detection on not just structured data, it could be even unstructured data. For example, I'll give you one very, very simple scenario. You see that normally when you are recognizing a traffic video as you're driving, it is one of the signals, right? Red, blue, or green. Sorry, red, yellow, or green. But some intersection, you are suddenly seeing that all the three are on, or two of them are on, always. What does it mean? It means the light is faulty, and that is an anomaly which can be detected only by a deep learning vision system. It's not something you can do it with a structured data, right? Only from vision system you can detect that it's not correctly specifying one of the three lights to be on. Instead, there are two lights on. So think about anomaly detection scenarios in vision, anomaly detection scenarios in text, anomaly detection scenarios in speech. All of them are scenarios where, for example, today there are interesting AI-based chatbots which are what we call as psychological aids to people who are having dementia or who are mentally retarded. What they do is they subtly remind them of what they were doing, what the context was, and they try to bring them up to speed. These are assistants to these people who suffer temporary loss of memory. Why is this important? Because it is not like you always have to monitor, you're only using humans to always look after them. You can have a self-service AI-enabled agents. To the level today, we have very, very production-ready technologies in form of AI-enabled smart canes, which can make blind people as good or as capable as normal human beings. They can guide them on every place where they are, what context is, what kind of objects are coming, what kind of traffic signal is there. All of that is possible to guide a blind person. So today there's a lot of work happening on what we call as assistive technologies, which are purely based on computer vision enabled by very powerful deep learning scenarios. Similarly, there is another area where we need to understand this is very useful. This is especially useful in case where you have lots of scientific data, which is unstructured. You want to make sense out of it. I give you an example, right? Higgs boson collider, or sometimes it's purely vision. Diagrams only of things are coming. You don't have actual structured data which is coming. Weather data may be restructured, but if you see astro data captured by telescopes, they're visual data. So you need to understand visual data as a first class object, just like what you do with a structured data. That's why deep learning is important.